Hello everyone, my name is Lucas and in this presentation I will share the results of our project titled Carbon Footprint Analysis of Food Packaging, a collaborative study between FEI University in Brazil and UCAB University in Venezuela. Before I begin, I would like to thank both institutions and our professors for giving me the opportunity to participate in this international project. It has been an incredible experience that allowed me to learn not only about sustainability and environmental analysis, but also about teamwork, cultural exchange, and collaboration across countries. The purpose of this work is to analyze the environmental impact of the food packaging used in both universities' cafeterias, focusing on energy consumption and carbon emissions. Beyond that, this collaboration also allowed us to exchange ideas and explore how different cultural approaches to sustainability can lead to innovative solutions. The main goal of this study is to propose strategies that can reduce the carbon footprint of food packaging used in university environments. To achieve this, we conducted a life cycle assessment using the software Granta EduPack 2025, which considers the energy and emissions generated from the materials production to its disposal. By working together, students from FEI and UCAB were able to share different viewpoints and ideas, enriching the analysis and promoting a diverse, multidisciplinary perspective on sustainability. The comparison included three main cases: Brazil, FEI, PELD, low-density polyethylene used in flexible packages, and in this case, sandwich package. PS, expanded polystyrene used in food trays, in our case, bread tray. Venezuela, Group A, polypropylene used in plastic cup. PS, expanded polystyrene used in food containers, and PET, used in all-purpose container. Group B, cardboard used in fast foods and takeouts, more specifically pizza box. Paperboard used to paper wrap the food. Tissue paper to sandwich wrapping paper. And expanded polystyrene used in food trays. Starting with phase results, the total carbon emissions were 51.6 kilograms of CO2, which represents a very low overall environmental impact compared to the other studies. Phase packaging achieved 100% recyclability, and because of its low mass, only about 12 kilograms, transportation emissions were minimal. This reflects a culture of efficiency and optimization, where environmental awareness is combined with practical engineering solutions. In short, phase systems demonstrates a well-structured circular approach to packaging and waste management. Moving on to UCAB Group A. This group presented a higher total emissions value than FEI, mostly due to the use of paper and cardboard materials that, while biodegradable, are not part of a recycling system within this specific model. The analysis shows that the transport phase contributes significantly to total emissions due to the distance considered in the model. From a cultural standpoint, this approach highlights creativity and adaptability, combining traditional materials with modern production methods. It represents a biodegradable-focused mindset, prioritizing natural and easily available materials in the packaging process. UCAV Group B showed the highest total energy and CO2 emissions, mainly because of the PET and PP plastics used, which require more energy in production. However, this group also included reuse and partial recycling in its model, which compensated for a portion of the emissions. The results show that long-lasting materials can balance initial energy costs by being reused multiple times. This approach illustrates a culture that values durability and long-term use, demonstrating that sustainability can also be achieved through extended product lifespan. After analyzing all reports, we focused on FEI's cafeteria system to identify improvement opportunities. Interestingly, the main source of emissions was not the packaging itself, but the refrigerators used to store snacks and fruits throughout the day. These refrigerators operate continuously and consume a large amount of energy. So, we simulated different scenarios in the software. Packaging 1. Current system with the large refrigerator. Packaging 2. Semi-packaging but reducing refrigerator size by half. Packaging 3. Preparing sandwich on demand, eliminating the refrigerator entirely. The result? By preparing food only when ordered, we could cut energy consumption by 100%, keeping the same packaging efficiency. For the second part of improvement, we also explored material substitution, replacing expanded polystyrene with cardboard, which is already recyclable at the institution. Packaging 5. Replacing polyethylene wraps with tissue paper, eliminating unnecessary plastic use. Each change was analyzed individually, showing a progressive reduction in energy and CO2 emissions. The result is a cafeteria model that could operate almost entirely under a circular economy, where materials are recycled and energy use is minimized. It is important to say that these comparisons were made through the implementation of gradual changes, considering the feasibility of implementation as well as what is already being done by the institution. To make these improvements real, we identified three main stakeholders that need to collaborate: the institution, the students, and cafeteria. First, the institution plays a strategic role as a manager of the system and agent for the formation of a sustainable culture. It is responsible for creating structural and educational conditions that allow for the reduction of the environmental impact of the cafeterias. A suggestion is to implement environmental management systems, partner with sustainable suppliers, and monitor key indicators. Second, the students, who are the main consumers in the cafeteria system. Their daily habits define the success of any sustainability initiative. Their role goes beyond participation. They must become examples and influencers within the campus. This change of habits can contribute to create a different scenario, improving the waste management. And third, the cafeteria, which is the operational link between production and consumption. It directly controls what packaging is used, how much waste is generated, and how it is disposed of. To start, they can apply practical measures, such as adopting greener packaging, training staff in waste separation, and reducing single-use materials. Together, these three groups can build a strong culture of sustainability within the university. To conclude, this project was much more than a technical comparison. It was an opportunity for international collaboration and cultural exchange. While each university presented different approaches, one focused on recycling and efficiency, the others on reusability and biodegradability, all of them share the same goal: reducing environmental impact and improving everyday practices. This study shows that there isn't a single path to sustainability. Every institution can contribute in its own way, depending on its culture, creativity, and local opportunities. Thank you very much for listening, and I hope this presentation inspires new sustainable initiatives across all our universities.